For 11a, we need to work out this integral here. So we can start by simplifying the integrand. So this x squared will cancel, and then we'll be left with x to the 4 in the denominator. So we've got then the integral of x to the power of 6 plus 1 over x to the power of 4. So that equals then, or we can write it as x to the power of 6 over x to the power of 4 plus 1 over x to the power of 4. And we can simplify this part here. So that 6 will cancel down and we'll get x squared plus 1 over x to the 4. So that equals then the integral of x squared plus 1 over x to the power of 4. So integrating that then, or that x squared, that is going to become x cubed, and then we divide by the new power, 3, and 1 over x to the 4, that's the same as x to the negative 4. So add 1 to the power, we're going to get x to the negative 3, and divide by the new power, which is negative 3. And then we add our constant of integration, and just tidying that up a bit, then we're going to get x cubed over 3 minus 1 over 3 x cubed plus c. B, part 1, we need to find the integral of cos of 4 theta minus 5. So one way to think about it is, all this integral sign here is asking us is, what function did we differentiate to get cos of 4 theta minus 5? So if we differentiate sine of theta, then we're going to end up with cos of theta. So let's start there, but we'll look at it in general terms. So if we have some function sine of a times theta plus b, and we're going to differentiate that with respect to theta, well, we just need to use the chain rule. So that is going to equal, well, sine becomes cos, so we're going to get cos of a times theta plus b, and then we multiply this, just using the chain rule, by the derivative of the inside here, this a theta plus b. So b is constant, so the derivative of a times theta plus b with respect to theta is just a. So we multiply that by a. So that means then if we integrate that, so we'll take the a outside because that's a constant. So if we integrate a times cos of a times theta plus b with respect to theta, that means we're going to get sine of a times theta plus b, and we just want the integral of cos of a times theta plus b, so we just divide both sides by a, so therefore cos of a times theta plus b, and integrating that with respect to theta, is equal to 1 over a sine of a times theta plus b. So we can use this formula here then to help us solve our problem. So if we're integrating cos of 4 theta minus 5, well then our a in the formula is 4 and our b is minus 5. So therefore our integral is 1 over 4 times sine of 4 theta minus 5, and then we add in our constant of integration plus c. Okay, so that is 11b part 1. B part 2, we need to evaluate this definite integral here. So in B part 1, we worked out the integral of cos of 4 theta minus 5. So that means our definite integral then, well, that's going to be equal to 1 over 4 times sine of 4 theta minus 5, and then we just need to add in our limits of integration. So we're going from theta equals 1.25 up so theta equals 2. So that equals then, well, 1 over 4 times sine of, well, 4 times theta. So if theta is equal to 2, 4 times 2 is 8. 8 minus 5 is 3. And then we subtract our 1 over 4 times sine of, well, here 4 theta, with theta equal 1.25. So 4 times 1.25 is 5. 5 minus 5 is 0, so we get sine of 0. So sine of 0 is just 0. So this then equals 1 over 4 times sine of 3. So that's the exact answer. And now we'll just work out on our calculator what that would be as a decimal. So just a reminder that when we are doing problems on our calculator involving calculus, that we are in radians mode. So 1 over 4 times sine 3, well, that is just sine 3 over 4, and that is equal to 0.03528, etc. So 0.03528, and if we round that to 3 significant figures, then we get 0.0353. Let's do 3 significant figures, and that is question 11.